Welcome to the second part of our second entry in the Master of None course series, which we've dubbed Sandbox in a Box. If you're coming here from not part one, the reason we've dubbed it that is because in part one we built a small static and dynamic malware analysis lab of just 2 VMs for now, made up of a Linux machine, which is the Remnux distro of Linux made especially for malware analysis, loaded with a bunch of malware analysis tools, and that will also be serving as our fake internet. And then we have our Windows 10 victim machine, also loaded with a bunch of, again, free monitoring and analysis tools. And now that we've gone through the work of building those 2 machines into our lab, we're going to put our lab to the test in this part by examining some real malware samples in it, taking a look at the tools that we built up and installed in part 1 in more depth, and just in general talking about different things to look for as you run malware samples through these 2 different sandboxes. We won't get into every single tool included on either of these machines today, but we'll get through a lot of the ones on the Windows machine, the majority of them in fact, and I'll also demonstrate a couple of the tools on the Remnux distro as well, although there are so many on that distro that I'd have to dedicate a whole video to that, and if you want me to, I'm willing to, but this is not that time. After we go through and examine this handful of samples, I also am going to issue you your challenge for this course. Just like the first Master of None course, the challenge will take the form of a Google form, no pun intended or double form intended there, except that the last one was just one question, which was what flag is in the CrackMe file. This one is definitely more verbose, but takes the same format. It has a bunch of questions relating to a file called crackme.exe, which I've developed, and it will be located in the GitHub repo for this video. In fact, that GitHub repo is also going to be linked in part 1, and it's going to be in the description of this video. It's got all the links we talked about in part 1, the CrackMe executable, and it will, at least, it's not this one, but it will have a wall of fame similar to the x86 assembly course we did first, that will, for all of those who fill in all these answers correctly, log your name and the date to this wall in what will be the second course repo, which is not up yet. For those of you who do write-ups for these courses, by the way, please shoot me a message, either comment on YouTube or a Mastodon message, or however you want to contact me, because I do like to link those in the wall of fame for those that do an extra write-up. I think that's always awesome to see. So yeah, that's what you can look forward to. And with that, I'm not going to go into any other introduction because we took care of all that in part 1. Let's get right into our analysis. I'm going to unpause my machines, which are back here. They're all in their clean snapshot. And for now, I'm going to blow up our Windows box. Let's go ahead into the shared folder. Today I have 4 real samples I'm going to share with you. And we're going to step through them together. The first one we'll be looking at is this XWorm sample, but we're going to treat it as if we don't know what it is, even though we know the family, the malware family right there. Now, all of these samples are free to download if you want to follow along from the wonderful Malware Bazaar. That's a service by abuse.ch. You can go here and go browse, and I'll link it in the master link file I'll have in the GitHub repo. You can do things like search by malware family, like if you want to search by tag for black suit ransomware. You can search by file type, SHA hash. If you want to see, how far back they go, you can look for something a little bit more commodity like Adwind. And you can see they have a compendium that spreads over multiple years. If you go into any one of these entries, they have a nice little IOC section, Yara section, sandbox summaries, and you can download the samples right here. It will be in a zip archive with the password infected. Wonderful service. Can't say enough good things about Malware Bazaar. So with that out of the way, let's go ahead and copy this over to our VM. So that was our shared folder, which if you missed part 1, that's shared between our host machine and our VM. I will say I'm not going to rehash a bunch of stuff from part 1 for those who did miss it. So I highly recommend if you get lost to go revisit that if you have not built a malware lab before, if you haven't done any malware analysis. But yeah, since we're going to treat this as we don't know what this thing is, let's go ahead and disable our shared folder once we copy it over. The reason I do that is because if I end up looking at something that does something like destructive, like a wiper or ransomware, I don't want it to touch anything in my shared folder, which is sharing file system space with my host machine. So we disable that. Let's go ahead and extract the file with the password infected. And we see we've got a PowerShell script here. So let's just talk about workflow for a bit. Like I said in the previous video, excuse me, I've been using this setup for about 7 years now, and I just updated a lot of the tools I've been using when we did part 1. But typically when I'm doing a blind run against a malware sample, if I can see the file type, I'll go in, like something like a script, I'll go in and try to read the script, give it an initial look through, see what I should queue in on as far as my other monitoring tools here before I actually run it. So let's go ahead and run this, or open this up in PowerShell IC. Don't run it yet. And let's take a look. So we're not going to analyze it deeply. We're just going to take a look and just eyeball it, look for a few key things here to look out for. The first thing that rings alarm bells for me when I'm looking at this is 4D5A. For those who may have done malware analysis or know their file signatures very well, sticks out to me because that's the executable file signature. So that tells me that there might be a embedded executable or two in this file. Excuse me. We can see that there's some .NET service stuff going on here, which is typical in malware that will like load up a .NET executable in memory and try to run it in the background without alerting the user. This is cool. We've got another PowerShell file being written to C users public. So that might be a directory we put something like capture-bat onto. Again, or capture-py, sorry. I used to use capture-bat and I started using capture-py. This Python script, if you remember, or if you don't remember, will monitor a directory, and if the malware goes in and deletes anything from that directory or writes anything there, it will capture that, so that if it does get erased for some reason, we will have our own copy. You can see a lot more interesting stuff here, bypassing execution policy to run PowerShell script. There's also variations of this, it looks like, because there's also a batch file of the same name. There's a VBS file of the same name. So this is interesting. Again, I'm not going to go through and analyze this. We probably could. It's not obfuscated or anything, so we could probably go through here and analyze it. But yeah, I'd say we should keep an eye out on that directory, and maybe anything to do with Microsoft Edge update, as that sticks out as an interesting indicator right there. And they were nice enough to let us know that they're going to run the script every 2 minutes, or maybe that's just a fake description. I'm not sure. Looks like they might actually be doing it. Anyway, it does not much matter for our purposes, because we're approaching this just to go in and see, okay, number one, what stuff on the file system is this file affecting? What are some indicators we can pull out to build detection signatures? What kind of files is it dropping? What kind of network activity is happening? All those things. So when I'm examining something that I'm not really sure what it's going to do, I'll typically run a suite of some of these tools here. So let's first of all, like I said, go to our desktop, run capture-py, and the syntax for this is just to give it which directory you want to capture files from, which was C users public, and where you want to save them. I'll just save them to a desktop directory called save. We'll minimize that. It's running in the background. Let's go ahead and open up Command Watcher. If you remember, this is the one from Kahoo Security that monitors VBS and PowerShell and other scripting type languages running. And it's really nice for deobfuscating scripts or checking scripts as they run to see what commands are running. So we'll open that. I'm going to open process spawn control, but I'm going to save that for last because it tends to suspend all my other tools as well. So that PowerShell script will suspend every new process that gets started and prompt you to either keep it suspended or run it, which is really nice if you have malware that's like, unpacking itself in memory or trying to execute something in memory and it tries to start a new process. You can halt it, dump it to disk, and then continue on if you want to. So we'll keep that for last because you also have to do that prompt for everything you open. And let's go ahead and start Wireshark. We will have INetSim running in our, where's my Remnux window? Right there. We will start INetSim here shortly. not yet, because I don't want a whole lot of noise in the log, but Wireshark, I always like to run them concurrently if I can, if I have the resources to, because you get a much deeper look at the web traffic with Wireshark, usually than with INetSim. So let's go ahead and run that. Process monitor or procmon is great. This is, as I described it in part 1, this is like Wireshark but for processes. So it will tell you all the different file system and registry and network operations happening for a process, but it does this for every process, so we do want to set a filter. Now, typically what I used to do is I would see if I could pull out a process name like PowerShell.exe or the name of the malware if I knew it, and do it by process name. A recent tweet clued me into the fact that the newest version of procmon has this wonderful filter called process start. So you can actually set it based on time. If we go anything started after that time, and that should filter out all the kind of like background noise and just focus in on what's going to happen when we run this thing. So let's keep that running in the background. What else? We want System Informer, previously known as Process Hacker, and you can see it already captured a bunch of info on that as it started up. So let me clear that out. And what else? I think that'll actually do it. This is typically my, oh my gosh. I'm so sorry. There is a ladybug literally crawling on my screen, and it looked like it was something on my virtual screen. 1 second. Well, I regret to inform that in the time it took me to go out and get a cup for that ladybug, it is gone. So it's somewhere in the office flying around. It's not part of our series here. And if you hear me gasp, it's because I found it again. Not that I have anything against ladybugs. I just wasn't really expecting that across my screen just now. Anyway, I am going to add a filter actually in procmon for PowerShell.exe because I'm getting a lot of noise. So let's go ahead and apply that. We should be ready. Let's go ahead and start up our fake internet, INetSim. Make sure that runs everything. Yep, okay. I was waiting to start process spawn control because when you have command watcher and process spawn control turned on, you'll see this in a second, they compete with each other because they're both monitoring for new stuff happening, and one of them will log what the other one's doing and vice versa, so it gets kind of annoying. And I've noticed, I don't know why, but in version 0.4 of command watcher, they used to have a manual mode where you could kind of auto accept everything, and they took that away now, so that's kind of annoying. But we'll deal with it. I'm going to start process spawn control first. That's going to set off our procmon as well because procmon is monitoring for PowerShell.exe. So let's clear out all those benign log entries. And by the way, you don't have to run all these tools I'm running. If you're hungry for resources, you don't have to run all of these at the same time. This is more benign stuff, probably from process spawn control. In fact, let's do this. While I'm talking, let me finish my thought. Yeah, you don't have to run all of these tools if you're hungering for RAM or anything else, or CPU or anything else. You can run these one at a time and then go back, restore your snapshot, run the malware again with another tool, go back, run the snapshot again with another tool. But since I am lucky enough to have a lot of RAM and CPU on this thing, I can run all of these and monitor multiple things at a time. One more filter I'm going to add is I'm going to exclude the PID for PowerShell running process spawn control so we don't accidentally pick up stuff from there. And with that, I think we're finally ready. Well, once we start Command Watcher, we're finally ready to start our malware. So right away we see the actual command, and like I said, they're like bouncers. They're like, hey, PowerShell's trying to run. You sure about this guy? You want me to get rid of this guy? Yes, go ahead and run it. Go ahead and run it. Process spawn control. You'll see some of this is going to be background noise. Some of it's going to be related to the malware. We're just going to keep our eyes peeled for anything that really sticks out as interesting. And all of this so far is interesting, but nothing that directly points me to, oh yeah, this is definitely the malware doing this. We do see a PowerShell window come up, and even though we set our execution policy to unrestricted in the last video in part 1, we still get this prompt, which is good. A savvy user would be tipped off when this pops up that something might be fishy about this PowerShell script. Although if they're clicking on this in the first place, maybe they're not so savvy. That tends to be the case, unfortunately. And then as quick as it started, it's gone. So let's take a look at procmon because I don't see anything else of note in Command Watcher at the moment. there's going to be a lot of stuff here, and sometimes it's hard to filter out the most interesting part of these. We do see it starts conhost.exe. We see a bunch of registry and like loading of libraries, but that happens with any kind of executable really. What I like to do when there's a lot of noise like this is filter on operation contains write and see if it wrote anything to disk, and look at that, where we have our capture bat capturing. In fact, let's look at our save folder, and we should see it's captured 3 different files that were in C users public, which is the path we saw in that PowerShell script, the original one. And they were not deleted, they're still there. So we can take a look at these. This batch script, and it's gonna, process spawn controls, making sure I want to run Notepad. Looks like that just runs the PowerShell. The PowerShell itself looks to be, allow it to run. You can see process spawn controls is watching everything I'm doing to make sure I want to run it. And let's see what this PowerShell script looks like. Oh, it looks very similar to the one we saw before, maybe a little bit different. I think the one we saw initially was longer than this, but it looks like it has that same sequence of probably executable data. And what was the other thing? The VBS script. So let's see. Open Notepad, allow Notepad to run. Yep. So we see that this is basically, getting the path to the batch. So it's all kind of self-referencing. Now what's interesting is, if you remember, we saw in that original script that it would run every 2 minutes. I think we just hit the 2-minute mark because now I'm seeing some other stuff happening with sc.exe, push to install, libraries.vbs wants to run. Okay, now we're getting some cool stuff. So let's do this. Let us, where do I want to focus? Let's focus on command watcher. Since we're going to be running wscript, command watcher is perfect for that. Let's go ahead and allow the run and allow whatever else is up here to run. And we see that called libraries.vbs. Let's see what else tries to run. Let's keep our eye on System Informer as well. Do we see anything from wscript? I may have missed it when it came across, but I don't see anything yet. Oh, because this is still waiting for us to allow it to go. So there it goes. Now it's running command.exe and the libraries.bat file, which is going to run that PowerShell file as we saw. There it is. So this is the malware running on that 2-minute schedule. We see another instance of PowerShell pop up. Let's see what happens next. Give it some time. We could also be monitoring the background. Obviously, we could be monitoring Wireshark and some other stuff. But like I said, we'll focus on one area at a time here, or try to, because there's a lot going on. regservices.exe. So this is what's, like I said, this is the .NET service register. This usually happens when the malware is trying to run some .NET executable in memory. Very cool. So let's see what's happening. We see a task scheduler entry there. Let's go ahead and I'm just allowing everything as it comes across. Process spawn control is probably getting overwhelmed at this point because I'm seeing that's freezing up some of these entries. So let me do this to help us out here. At this point, I can see this exe running in the background. Let me just make sure all of these are accepted so that it can run before I close out. But then I'm going to probably close out of process spawn control to save us some resources here because it's capturing a whole bunch of stuff. So let's do that actually. I think what I can do is, oh, and now the 2 minutes started again because I see them all running again. Let's do this. Let's go ahead and stop command watcher as well so we're not halting the malware from doing anything. And let's just watch what happens in System Informer over here. So is this suspended? No, it's not suspended. So we see PowerShell running again. We see another instance of reg services. That one has terminated. And I don't see anything else yet. This one is still going. So it might be that the next one terminated because it detected that this one was already running. Ooh, sorry, that was a lot happening. What do we do now? Well, at this point, once I see a new process running, again, we don't see a window or anything else going on here. Or I guess, oh, maybe we do. Sorry, that was just waiting there. I think that was, I don't know if that was the malware or if that was process spawn control. I guess we did see a GUI window of some sort there because it seems to be running now. Okay, well, never mind. I feel like that would have tipped off the user as well if that was from the malware itself. But again, you never know what the user, what they're going to think is bad or good or whatever. So yeah, it looks like it's still running. It's not suspended. Anyway, what I was getting at is when we see a process, a new process like this started, and we don't see, you know, any kind of indication of where it is on disk because this was just built basically in memory, we can now turn to our admin level command prompt, go to desktop, and see the power of pe-sieve, which was another tool I touched on lightly in part 1. So all we have to do is pass a process ID to pe-sieve, in this case 7508, and it's going to scan that process for any injected executables or DLLs or anything suspicious looking in the memory space of that process. And right away we pull out the process itself at, this is the address it was loaded into, and a DLL. In this case, I am most interested in what the heck this exe is doing in the first place, or what it is. Since it's a .NET executable, we can go into dnSpy, and I'm actually going to close procmon. Actually, let's actually look real quick before we close procmon and spoil the surprise. Let's focus on this exe here, and let's get rid of our other PowerShell filters, or at least the one that is adding those entries. And did I misspell that? I might have misspelled that. Reg svs sv, yeah, cs is what I should have put in there. There we go. So we see a couple of different files written, which is cool because now we can see, oops, not roaming, but rather app data. We can see, oh, there's our file on disk. So we didn't actually need to dump it from memory. We could have found it on disk thanks to procmon showing us where it was. Interestingly, though, we also see a temp log being created, which is really cool. Let's see what that's all about. Notepad it up. Oh, well, it's logging what I'm doing. Interesting, a keylogger. Okay, so we are getting a ton of great information already just from using these tools like procmon, looking at where things are running with command watcher, halting things with process spawn control to see if we can examine them, dumping them to disk with pe-sieve. Let's go ahead and where do I want to go? I want to go to my desktop where pe-sieve dumped that executable. We could also take it from the directory it was written to in app data, but I'll pull it from here. And well, we've got ourselves a .NET executable that looks very similar to some of the RATs we've looked at in like the AsyncRAT and the RAT King Parser video. And this is how we can go in here and determine its XWorm just by looking at this code. If you look through, actually, let's do this. I'm not going to get into .NET reversing right now, but if you look at the other videos we've done with AsyncRAT and RAT King Parser, we talk about this quite a bit. You can go here, look at the entry point. Typically, you'll see a section that looks like this, which is a configuration. And if we go here, this is our encrypted configuration right here. And we can see our log file taken right there. Now you may be thinking, why didn't we make a module for XWorm in the RAT King Parser video we did? I was thinking that same thing. I think we should probably add it. It's slightly different, so I don't think it's going to be an easy one-to-one mapping like we did with AsyncRAT and DCRAT, but I am planning on taking a look at this later to see if we can implement it. But that's neither here nor there for now. For now, all you need to know is that this is an encrypted config, and if we wanted to decrypt it, we could either look online and see if there is a decryptor for it, or we can cheat, use dnSpy to set a breakpoint here. In fact, let me blow this up. I'm sorry, I just realized this is probably quite small for you to look at. Let's zoom in. Set a breakpoint by simply right-clicking and setting breakpoint, or doing one of the hotkeys, or clicking on the line. We can run it in dnSpy, and we should be able to break right when this conversion happens so that we can check the converted value. So let's see what happens once we step over this line. Well, we've got ourselves a C2 server at duckdns.org. We've got ourselves a port. We've got ourselves some kind of key. I don't know what that is, to be honest. I haven't looked at the XWorm configuration. We've got a pretty good identifier that this is XWorm. So if we were not sure of what it was before, we are pretty darn sure now. We've got a file name, usb.exe, which is interesting. And we've got a app data directory, which is where, of course, it stored the exe itself. So a bunch of great indicators we can use for detection. Now that we know where it was reaching out, let's head over to, Wireshark here. Look at DNS logs, and we see a bunch of noise here from, I'm sure there's more telemetry kind of reducing or reduction I can do on here to get rid of some of this noise, but let's do some filtering, I guess, and take a look. Actually, we do know the port was IP, what was it? It's TCP. Port equals 7000, because that was the port we saw in the malware. Oh, actually, we're getting a bunch of resets. Do you know why? It's because we don't have 7000 as a port on INetSim, so I'm actually super happy this happened, because I can show you in the first part when we did our INetSim configuration, I didn't really touch on this, so this will be a good point to do that. Excuse me. If you go to the configuration, oops, that's not it. That's from our last one. If we go to the configuration for INetSim here, well, before we do that, actually, I do want to point out, if you look at this log from our initial run, you will see the DNS connection to INetSim for that duckdns.org. So that's one way you could get that. You could also get it from Wireshark. But secondly, to actually get the malware to think it's connecting to that site on port 7000, we have to go into our configuration and we have to set our dummy bind port, which is basically just an extra port we get to set up a service of whatever kind we want. So let's tell INetSim we want to listen on port 7000, run it again, and let's see what happens now. At the bottom here, we're getting some traffic. So let's follow this new TCP stream. We've got a POP3 response. That's just the default that INetSim treats it like POP3, so it's treating it like that. But we can now see some data being exchanged between our computer and the attacker computer. So you could potentially see C2 traffic going back and forth here, although I'm not sure what it's sending at this point. It could be encrypted. There's a number of different things, and we could probably adjust INetSim to make it respond in a more, I guess, non-POP3 way to make it think it's more realistic if we knew what kind of protocol the malware was using. But for now, this is just fine. Thought I lost my, okay, I thought I lost my connection there for a second. So that's really neat. If we had any postbacks, for example, right now I'm seeing just a bunch of push here, but if we had a post or an HTTP call out or something, we could track that in INetSim and Wireshark as well. So now we've got the malware thinking that it's actually communicating back home, which is really cool. Like I said, I don't know if we'll see anything super, yeah, we've got nothing in the logs for INetSim, so we're not seeing anything super, crazy there. But let's do this. Let's change, instead of using the dummy port, let's bind our HTTP service to 7000 instead, just for now. Just for this run to see if it responds differently if it thinks it's connecting on HTTP. So let's see what happens. So we've got more traffic here. I don't think we're seeing anything too much different. We're seeing just that same kind of probably encrypted data or encoded data being sent back. I don't see anything much in plain text. Still, I just wanted to demonstrate that you could experiment around with INetSim, play around with those options, see if the malware changes its behavior based on what kind of service or what kind of ports you have being monitored. But yeah, really cool. It really doesn't matter in this case, looking at Wireshark or INetSim, because now we really have not the original source code, but pretty darn close to it right here. We could probably run through here, do a more thorough analysis, and find out exactly where it's sending that, network data, how it's encrypting or encoding it, and get some more and more information out there. But at the end of the day, we've already got a ton of great information about this XWorm sample. We've got its C2 address. We know which port it's going after. We've got all the artifacts from the file system where it writes to this directory and, it writes itself to app data. So yeah, our lab has done its job and given us a leg up on writing a bunch of detection for this malware family. Really cool to see. I could spend a lot more time going through, I will spend a little bit more time going through System Informer, but I could spend a long time going through all these other tools here and looking at all these entries, but I don't think we need to get that deep. I'll leave that as kind of a learning exercise, if you will, for you all. What I am going to do is show you, once I stop process or command watcher and close all these, I'm going to show you one of the most powerful features of System Informer. And that is, if I didn't want to do anything I just did, if I didn't know anything about the file, if I didn't have procmon running, if I didn't have dnSpy open and looking through it, and I wanted to look through and see if I could find something interesting, I could go to the properties for this by double-clicking it or right-clicking it, memory, and I can search for strings. So let's say I want to search for anything with HTTP in it. Or I'm sorry, I don't need to search here. I need to, where I want to go? I want to go to here, option string. Sorry, this has been modified since the last time I used Process Hacker, so I wasn't sure where it was going to be. I tend to go for the minimum length of 4, which I think is the bare minimum you can do. I don't think, if you go to 3, I don't think it, yeah, it must be 4. So find all strings that are a minimum length of 4 or more. And this will pull out all the strings for us. You can also do this in IDA or Ghidra as well, but it's nice to be able to do it in memory because Ghidra and IDA won't pick up, or they'll only pick up strings that are present in the file as it stands on disk. System Informer, I keep wanting to call it Process Hacker, will pick up strings in memory. And so if we want to look for something like HTTPS, we could find, well, we're going to get a bunch of library names as well, but we could potentially find something. In fact, let's change our filter to HTTPS// You could potentially find URLs in here. If you wanted to find, for example, well, let's take the DNS or the C2 server we saw, and we just want to search for .com or .org. Again, you're going to get a lot of false positives with .com. Let's try to find something, something a little bit more. Here, let's do this. Let's use regex, and let's do like A through Z 0 through 9 dot or plus dot A through Z 0 through 9. This is, if you're not familiar with regular expressions, we're basically looking for any alphanumeric characters plus a period, one or more. That's what the plus symbol is, one or more, another period. So something that looks like a domain, basically. That's better. So we not only have some potential user agents here, which is really cool. We have some, this is unfortunately going to hit on a bunch of version numbers as well. So let's make it A through Z only dot A through Z lowercase, and I'm sorry I forgot my plus. And let's see if that narrows down from those version numbers. You could play with this a bunch and play with your filters. So we're also going to get a bunch of these .NET module names, which is fine. What I'm really looking for, and maybe I should be even more specific in my regex. Yeah, let's do that. Let's do this. Let's do A through Z, one or more, period, and let's do either .com or .org or .net. That's more like it. Okay, so yeah, you can play around with the filters as much as you want to filter these down, or you can really, you don't have to filter. You can go through all the strings if you're insane and really want to do that. But if we filter down on just that pattern, we can see our C2. So we didn't have to open up dnSpy or look at anything else for that. Of course, we could have just gotten that from our DNS logs in Wireshark or in INetSim as well. But all that to say that you can find the same data we saw in dnSpy, like log.temp, this file path here, just by looking at the memory strings as well. So this is really powerful. You can look for a lot of different indicators of compromise or file paths, or even just interesting strings that might be good YAR role candidates or detection candidates in memory using this feature. Again, if you just try to look through the raw list of strings in memory, especially since we filtered on a minimum string of 4 characters, you're going to get a lot of noise. But in that noise are some really good nuggets. You just have to be able to filter and play around with the filters to home in on them. All right, let me think if there's anything else I want to show with XWorm here. I think we've seen quite a bit. I mean, I didn't even talk about, there's also, incredible .NET support here. You can see all the .NET assemblies in here being imported. You can see the environment and if there's any command line arguments applied, all that good stuff. You can see where it's running as well. So I think this one is going to show, yeah, this guy right here. I don't know if it will show us, yes, this command that originated it, which is really nice. So again, System Informer has a ton of great features to kind of have good look at something running in memory in real time that you won't be able to get with something like IDA or Ghidra or some static analyzer, which is really awesome. But yeah, with that, sorry, I'm really excited over this. I'm glad everything, it's nice always seeing everything come together because I hadn't really tested these in the new lab yet because we just built it in part 1. So seeing it come together, hopefully that's exciting for you as well. And I don't think there's really anything else I want to show with XWorm. I think I'll save some of the other tools for the other samples. So the nice part about our lab is all we have to do is close it, restore to clean. We don't really have to restore to clean yet on our Remnux because I'm just going to keep running INetSim in there. So we'll just keep that open. And let's move on to our next sample. So for our next trip, let's look at this suspicious document, because if you remember in the last part, we downloaded LibreOffice and I had mentioned that LibreOffice does have support for macros. So if we open this, again, I know what this one is, so I'm not going to actually turn off my shared folder this time, but last time we did that just as a simulation. Before we open this, excuse me, let's go ahead and open Command Watcher and process spawn control. Again, this is going to get a little bit annoying probably because they're going to fight with each other. And they're also going to fight with all the background processes going on, like that, Microsoft Edge update. But let's go ahead and back to LibreOffice, enable macros. If you remember in the last part, we, yeah, here we go. So let me finish my thought first. In the last part, we finished, or we set our security settings to only prompt or do that prompt pop-up we just saw to tell us that a macro is going to run, but we did not prevent any macros from running once we click OK on that prompt. The other thing I said in part 1 is that LibreOffice's macro engine is slightly different from Microsoft Office's engine, and so you'll get times like this where something just won't work, or you get an error or something. And it just is one of those things where you either fork over the money to buy Microsoft Office and put it in your malware analysis lab, or we find a workaround, which I'm going to show you what the free workaround is in just a second. First, I wanted to just show you how bad of a, typical but bad of a document this is, basically prompting the victim to enable the macro to run. And I'm going to go ahead and close Command Watcher because this macro is not going to run. Spoiler alert. And process spawn control. I really just opened those to show you what I would typically do when running macros, just to monitor for anything new coming up. Let's go ahead and close this out, and that should close all those windows. So what to do if we can't run this here? I mean, we could go through tools, macros, edit macros, and take a look at it and just see if we could derive what's going on here. If we open up this document and look at some of the stuff in here, it's a bit difficult to determine exactly what's going on. Unless you're, unless you're a VBA master, you might know exactly what's going on here. But since I don't, here's what I'm going to do. I'm going to take take advantage of the use of some of these awesome tools included with the Remnux distro. So like I said, I do want it to demonstrate at least a few of the tools on here that I find really useful. One of those being, well, I don't want to spoil it yet. Let me unzip this first. Unzipped out our doc. First of all, before we get to the tool I'm going to use, there's also a ton of VBA and OLE type tools on here for browsing any kind of macros and documents. So we point it at this document, it'll show us all the macros in ollie browse. If we do ollie dump on that file, it does the same kind of thing. Ollie VBA on that file, it gives us a nice little breakdown of what's going on here, and it kind of calls out some interesting features like function names, stuff like that, run when the document is open. So we can use all of those to determine if a document has a malicious macro, but what do we do if we know it has a malicious macro and we just want to analyze it? Well, there's a wonderful tool called ViperMonkey. On Remnux, you can just run the vmonkey command. And what we want to do is actually give it a file, but I just wanted to show you kind of the basic description here. So ViperMonkey is a specialized engine to parse, analyze, and interpret Microsoft VBA macros for malware analysis. So it's almost like a isolated environment to run the macros or attempt to parse out the macros without having to buy Microsoft Office. So let's point this at our file and let's see what we got here. So I don't have the Excel. It keeps saying, what is this? The XLRD thing. I think that was also in the ollie VBA. I don't have that package installed, so it's going to, yeah, psutil. So that's not going to work, but we don't really need that bit because, oh, sorry about that. Okay, I was looking in the log output and I wasn't finding it because it's not there. But what will happen is at the end of that log output, there will be an artifacts folder created. And within this particular artifacts folder, there was an embedded, oops, let me ls again. There was an embedded executable. We can see that if we run file on it. It's a 32-bit executable for .NET. Well, that's cool. Let's go ahead and zip that bad boy up. We'll just call it embedded.zip. And then we'll put a password of infected on there and pass it back over to our Windows machine. Again, be very, very careful moving things from VM space to shared folder space. Always make sure it's zipped up nicely. And once we get that exe back here, we can treat it just like we treated the XWorm exe. Let's go ahead and rename it to .exe. This is actually a good opportunity to use detected easy or die. We can pull it in over here. And detected easy lets us know that it is in fact a .NET executable, binary format, very cool. If since we already know it's a .NET executable, we could just, click the easy button, pull it into dnSpy if we had some reverse engineering knowledge. And we can see, oh, car race game, interesting. I'm sure this is actually a car race game and not something completely malicious. But yeah, we could dig into this in dnSpy and see what it does. But instead of doing that, we're going to do another easy button. Let's start up our typical suite of tools. I'm not going to start Command Watcher. Or do I want to start Command Watcher? No, I think for now, you could start Command Watcher. For now, I'm going to start, number one, INetSim. Monitor for anything on the network in my Remnux box. I'm going to start System Informer. Let's do procmon to monitor anything going on. And what do I call this thing? Let's put a filter on for that file name. And let's lastly do, we could do Wireshark as well, but I'm going to leave that off for now. I feel like there's one more thing. Oh, process spawn control. That's what we're going to do. And let's run this thing and see what happens. Right away, we're getting some stuff. Let's go ahead and allow it to run. And you can see, even though we haven't even run the file yet, there's a lot of loading of libraries and other registry stuff going on. So sometimes this can be a bit noisy. I'm going to clear that out so that we can make room for all the stuff it's going to do once it actually starts running. And right away, it looks like, let's see. Yeah, we see .NET libraries, blah, blah, blah. Again, I'm going to filter this just on operation contains write, because that tends to be a very good one. Although in this case, I don't see it writing anything. Make sure I put that in right. Yeah, let's go ahead and remove it. apply OK. So we're not seeing anything written to disk yet. We do see quite a bit of registry activity, including some for Windows Defender, which is always interesting to see. It could be looking for whether that's enabled or not. And look at this, we're seeing another, hold on, let me just pull this up in System Informer. Yeah, this is a different PID, so this is a new instance of that process running under 1040. It was previously 6788. Timeout.exe, command.exe. Oh wait, before we run that, I do want to run Command Watcher just to see what it runs on the command line. Oh, I may have just locked myself. This is the trouble with using process spawn control and Command Watcher at the same time, as I may have just locked myself here. 1 second. All right, well, since Command Watcher and process spawn control keep fighting with each other, and again, I just looked up on the Kaho security site. I see that they uploaded a post about the update to version 0.4 where they removed the manual mode where you could just let it run, but they don't explain anything about why they made that decision. So I can't, I don't think there's a way anymore to auto accept all these prompts. So regardless, we'll just work with it. We will keep Command Watcher open. We'll keep process spawn control off for now. We could always go back and set a snapshot and like go back and run process spawn control as well. But let's go ahead and just run one or the other. This time we'll run Command Watcher, let all this stuff run, and just monitor the commands being run here. I'm not too interested in any of these yet. I'm really looking for anything that immediately kind of, speaks to me and says, hey, this is writing a file somewhere or trying to start a different process or adjusting something that it shouldn't be touching really. So let's let that run for a minute and just see if anything else happens. In the meantime, again, we could be clicking in here, looking at memory or strings. Sorry, I keep going to memory because that's where it used to be, but strings, let's say, and let's set it to a slightly higher 7 this time. And we could be looking at some of this, and look at this, hold on. This is unrelated to what we just did, but it looks like it's calling another instance of itself, which is fun. So it might have had a sleep timer as well. Oh, interesting. Okay. In temp, there's now a batch file, which again, we could capture that with capture pi, but since it's just there, let's go ahead and open it. Open. Oh, and it's starting a Windows driver.exe. So let's take a look at procmon. And if we had looked in there first and filtered by writes, we could see that it did indeed write both the batch file and Windows drivers.exe, which just based on that file name alone, I'm guessing is not going to be great. And it's now trying to run that batch file. So yeah, I'm actually going to close this now that we know that, because I'm now going to focus on what's going on with Windows, whatever it was called. Where was it? Roaming, Windows driver, whatever it was called. Is it Windows driver? Windows drivers, yeah, sorry. App data, Windows drivers, there it is. So we can bring that into Detected Easy. And by the way, let's go ahead and set a filter on that as well. It's Windows with a 0 driver z.exe. And we can see all the neat things that it's going to do once we start running it. But first, I just want to drop it in here, see what kind of file it is. And we've got another .NET executable. Very good to know. Let's go back to Command Watcher and let it rip. There it is right there. Again, if for some reason that wasn't on disk somewhere, we could also drop it out with a quick call to pe-sieve.pid or /pid 2080, which would dump it to disk for us on our desktop and any other suspicious regions. Right now I just found one, which was the executable itself probably. Or no, it was actually a DLL that it found, which is interesting. I'm surprised it didn't pick up on the actual process, but maybe it's because it wasn't, it's probably because it wasn't running in memory and it was on disk, because yeah, that makes sense. pe-sieve is made for detecting if there's an executable running in memory in a memory process of a different executable. And since this one's running from disk, it's not quite the use case for pe-sieve. So hopefully that makes sense to you, but it makes sense to me why pe-sieve is not dumping it, because we already have it on disk. So I just saw another call out to Windows drivers. I don't see too much else happening in procmon, which tells me I probably messed up the name. Windows, let me just straight up copy paste it, because we should see at least some oh, that's because I'm filtering on write still, that's why. So let's clear out that. There we go, that looks better. So now we can see a bunch more other stuff. We can see Windows driver starts up here. I see it touching a bunch of Defender stuff, so probably looking to see if Defender's enabled, maybe attempting to disable it. I wouldn't know until I went through all of these different logs and took a deeper look, but we can at least see that. What else? Different policy, a lot of Defender stuff. Some .NET entries here, which makes sense because it is a .NET executable. Some registry keys. I don't know what those are yet. I'd have to go through and look them up. What else? Anything else stick out here as interesting? It's creating another process of Windows drivers.exe itself, basically. I don't see any writes yet, at least to a file. I do see some other stuff running in the background here that I'll go ahead and sit through. There was a service install, it looked like there for a second. And I'm just looking at this column right here in operation to see if anything else sticks out. I'm actually going to close, this is Google Updater running in the background. I'm actually going to close or stop Command Watcher for now. We'll still retain the log, but I'm getting a little sick of clicking through those pop-ups. Let's see, what else? Yeah, I'm just going to get a quick once through of this. Seeing if anything else really sticks out to me as a red flag as this runs through. I mean, all of this so far looks like something not good based on its querying of Defender and the file name itself just being odd. I was just going to see if anything else in the file system stuff. Oh, here we go. Down here, first of all, lots of cryptography entries, which is interesting. Maybe some encrypted data stuff going on. More importantly, right here, procmon is getting a connect out to 7707. Yeah, port 7707. So there's a couple things we could do with that information. Number one, I'm going to start up Wireshark, see if we can capture it live. Let's also go in here, and I'm just going to do a quick string search for, oops, sorry, I hit my mic there, 7707. And sometimes, just looking in the region where this is, there's actually a few ports listed here. We might look at the adjacent memory and see some interesting strings. Now in this case, I don't see anything yet. I could look at some of these as well. But again, just another tool in your toolkit that you can look through some of these memory regions and see if anything pops out in the same region that looks suspicious. But since we don't, let's do this. Let's go back to Wireshark. One thing is that we do need to go back to INetSim, just like we did last time, and start that dummy port on 7707. But before we do that, let's take a look in here to see if there's any cool DNS entries that are not Microsoft. So far, I don't see anything that is not a Microsoft or Google thing, and that might be because it's not getting that port. So let's go to our configuration again. Let me just look up if I have it. Yep, right there. Let's change this to, oh, you know what? I should have caught myself with this. I need to change that back to the default port. That might be a reason we're not seeing anything, but I think more likely it's because we don't have it listening on 7707. So let's try that. Run it again. And it may not be trying to resolve any domain as well. If it has an IP address hard-coded in there, it may not be trying to do any DNS callout at all. And we do see some of these other ports coming in. So we see 5200, 8808 as well. So it might be trying multiple ports, which is really cool. You can see that in real time. So let's see if it goes back to using, maybe instead of waiting for it, we'll just wait. And I just noticed it is using an IP address because in Wireshark we're seeing a 194 address, which is nothing of ours. So let's open up port 5200 instead. I'm doing this on my other monitor. I'm just setting the dummy bind port to 5200, rerunning, and let's see what happens. Now we're listening on there. We'll see if it actually reaches out or if it's going to switch ports again right after I did that, which would be the story of my life. Also, while we're waiting for that, another thing worth mentioning is you can see network activity in System Informer as well. You should see it if we go down here, yep, right here, you can see it, and it'll actually show you that IP, that same IP address right there at 5200. So that's really cool. The other thing is that since it is reaching out to 194.5.97.41, we may not see, I'm not positive, but we may not see that traffic on INetSim because it's reaching out not through our gateway, but through directly to an IP, which is interesting. There we go. You know what it was, is I forgot to rerun this command, which we did in the first part, but I think you actually have to run it. I don't know if I just didn't get it on the snapshot or if you have to run it every time, but you have to run accept all IPs on your interface over in Remnux, which is, for me, this interface. And that seems to have let us now finally see some traffic to that port. And again, there's not much that's plain English to be seen here, but it is good that we are now seeing a back and forth conversation at least. And again, we know that it's not going to a domain this time, but rather to directly to an IP address. So that's cool. We got some networking information out of it. Again, we could go into System Informer and we could do something like this to get the same information of making a little regular expression to look for something that looks like an IP, maybe something like 0 through 9 plus, period, 0 through 9 plus, period, 0 through 9 plus. It's very brutish kind of pattern, but it works. So yeah, you get lots of version numbers, but you also get that IP address right there, as well as localhost. But that's another way, just showing you there are multiple ways to get all this information, this detection information from different tools. So it's nice to have options. All right, next thing we're going to try is, we tried this on the initial exe that we ran, but we haven't tried it on Windows drivers.exe yet. Let's do a pe-sieve on 7236 and see if we pick up anything now. And we found total suspicious 4, including this guy right here, which may just be our the same file we looked at earlier, but let's go ahead and open it up in dnSpy and see if anything's changed, because sometimes it'll rewrite some stuff. Let's close this one, close this assembly here, and let's pull this one in and see if anything pops up now. Now it has changed. So before it was something completely different. It was a car racing thing. And now we see, if you've watched any of my other RAT videos, something very familiar, client dot etc, 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 which, you guessed it, if we go into here, go to settings, we got ourselves AsyncRAT. And again, we could go through and set a breakpoint. In fact, let's go ahead and just show what this looks like in dnSpy. Again, I've looked at this extensively. Oh, it's 32-bit. Well, we won't do that then, because we're running 32-bit or 64-bit dnSpy. But the great news is that in one of our previous videos, we wrote a parser for just this malware family. So let's go. I actually, this is not something I recorded in part 1, but I dumped the RAT King Parser on this machine as well as Remnux. So you can run it on either one. Let's actually cd into RAT King Parser. And this is the parser we wrote in my last video. And it's actually been improved quite a bit since then, thanks to a lot of not just contributions to the code, but contributions in messages to help improve it. So thank you very much if you're one of those people. But we can run this against our file, which is going to be in downloads, or I'm sorry, no, it's not yet. It's going to be in desktop, and then process72 whatever, and then this file name. And actually, let's clean this up by running that through Python techm.json.tool. Look at that. It's great to see RAT King Parser doing its job well. It has detected this as AsyncRAT. It's showing us all those ports, which we also derived from our memory as well. In System Informer, same thing with the host. It's got localhost and this address in there. And we can see it's installed in app data, roaming. We got the mutex, which is also a great detection signature, and some other stuff in here. So that's awesome. It's really great to see us come full circle, not only in this Master of None course, but also harken back to the RAT King Parser as well. So that's really cool. We've got ourselves a AsyncRAT sample here. And again, you could also open this up in dnSpy to go look at it. And keep in mind what the error message we just saw said, that you need dnSpy 32-bit. So if you did want to look at that, I think, let me just double check myself, but I think you need to install that release separately. We've only installed the 64-bit version on here, so that might be a gap that you may want to install both versions. For me, I'll probably do that later on if I need to. I'll just keep 64-bit on there for now. But yeah, that's I think that's all we'll do with this one. I'm trying to think if there's anything else I want to look at. I mean, we could look at procmon and see all the stuff that it was looking at here. Again, I don't think I saw like a log file or anything written, but let's just do one more check to make sure that we didn't miss anything. Actually, I already have this filter. I just have to turn it back on. Oops, I didn't mean to add it contains W though. Let's remove that one. Apply. Yep, we only see the batch file and the writing of the executable itself, so it doesn't seem to be writing anything to disk that we can see. It's just phoning home over the network, which we do see in both Wireshark, or in all three of Wireshark, INetSim, and System Informer. So again, you can get a ton of great indicators and detection signatures written from those indicators from a multitude of different tools that we have on this box. So with that, I am pretty satisfied with how far we got with that one. Let's move on to the next one. All right, so this next one, I'm not going to spend as much time on the file system and other stuff that we've talked about the last two samples, just because you've seen it by now. And there's another reason, and that is that we're actually going to pivot from our Windows machine to examining this with Remnux, because I want to demo one of the built-in tools of Remnux, which is great for this sample, and also an additional one that we added in our previous video. So let me turn on INetSim just to do our usual setup before we run this on our Windows victim, and then we'll pivot over a little bit. Sometimes this happens where Edge just wants to open. Sorry about that. That will happen sometimes though, and it will just show you the INetSim page. So Adwind, this has been around for many, many years now. And if I remember correctly, it's not, I mean, it is a malware family in itself, but it's also a malware platform as a service. So sometimes being used to deliver other things. But yes, it's been around for a while. Typically comes in a Java archive or jar format. So let's just, well, let's go ahead and do procmon at least, just to call out. We're just going to kind of speed run this one because I really want to focus on the Remnux side, but let's go ahead and do set up procmon for it. We will want to probably, yeah, let's do java.exe because this is going to run within Java. I think that will get us what we want. We're also going to want command watcher because if I remember correctly, and again, I'm cheating a little bit. Usually I'd run a bunch of these tools, but this time I'm taking shortcuts and just running the ones I know are going to be helpful here. And Wireshark, why not? I should have done that after or before I started Command Watcher though. Let me do that real quick. Let me stop this so we don't get a bunch of stuff as Wireshark comes up. Monitor on Ethernet. We got INetSim running in the background as well. Restart this and let's go. So you can see there, it's actually going to call javaw.exe. So let me adjust that. So there we go, java-w.exe. We're already seeing some things there. And let's go ahead and allow it to run. Woo, lots of stuff. So hold on 1 second. Let's filter this down because I saw an interesting tidbit that looked like it may indicate, yep, something was written to our home directory. Again, if we were afraid of this being deleted, we could also run capture-py doing something like this. C users lab user, and then save it to the desktop. I think in this case, if I remember though, this one does not get deleted. Let's go take a look. There it is. A JScript, not to be confused with JavaScript, but a JScript file that is very obfuscated. So, I'm sorry, this is all stuff running in the background. So we're not going to get much out of this unless we spend some time de-obfuscating it, or we can take a shortcut, of course, and just let Command Watcher keep an eye on it. So let me close out of capture-py because we're not going to use it in this case. I'm going to undo the filter and keep an eye on some other stuff that's going on. And we probably won't see too much else because I think what's going to happen next, as we saw down here, is it's going to call that with WScript, and WScript is instead where we're going to see some of the next activity take place. So let's go ahead and change our filter to WScript.exe. Lots of cryptography stuff, interesting. What else do we see? I'm just trying to look through the operations again and see if anything just stands out. It looks like some networking stuff, so that's good to see. Let's filter this on, oh, here we go. Hold on, there's a TCP there. Looks like it's going to our INetSim box for sure, but we don't know exactly what site or domain it was trying to go to. So we'll take a look in either Wireshark or INetSim in a second. But what's interesting is right after that network call, we see a call to, or a read from this guy right here. And maybe, what is this guy? This text file here. Looks like it was written around the same time. Oh, look at that. It looks like it's a zip archive. So that was what was downloaded there. And we probably, actually, can we, if I filter for write again, may see that being written to. We sure do. But yeah, it's also written this jre.exe, which if we unzip this, we're going to find out, sorry to disappoint, we're going to find out that that is number one. Oh, hold on. What's going on here? Okay, yes. So it could be that, oh yeah, it's 1 kilobyte. So it could be that this is, let me open up Notepad real quick and pull this in. Yeah, it's pulling down the INetSim default page. So it didn't actually pull down a zip file. It pulled down what it thought was a zip file. This, on the other hand, oh, this is a jar. I'm sorry, I just saw it now. And this may actually be, let me rename this and see if that is the case. We could also do it, I mean, we can do this too. 7-zip, hash it with SHA-1. We got that. If we go back to our original jar, it may not be the same, but this is one way to quickly check if it is. Yep, different. So let's see what that is, because that's kind of interesting. Let me just confirm it is a jar file and not a actual zip file. Oops, zip file. Yep, okay, yeah, we see that is indeed some Java stuff. So actually, let's zip that up, and we're going to bring that over to Remnux in a second when we go look at the other one. So let's do add archive, put a password on it of infected, and we'll put that in our shared folder for analysis back in Remnux land. Before we do that, just to wrap up the Windows side of this, we could, like I said, filter in here and look for HTTP traffic, because we did see that in System Informer, or I should say, does it come up separately? It should just be under HTTP. Yeah, oh, there it is. Sorry, I just missed it among the connect test traffic there. We do a follow HTTP. We see a request out to jv/jrex.zip, and it's at this host right here, wishsoft.company, and because we're running INetSim, it just sent back the default HTML page. Now, if we wanted to, we could go on a non-attributable machine, pull down that zip, feed it into INetSim, and let the malware keep running to see if it would change its behavior, and it probably would. But in this case, we don't need to do that because I'm going to show you a little cheat code over on the Remnux side. So again, if we wanted to, we could check this log here, and we could see the same data we saw in Wireshark, although I'll just do a search here so you can see it a little bit easier. Or it's Wishsoft, sorry, I think I typed host, but it's wishsoft.company. So yeah, you can see the DNS and the HTTP request right here, and INetSim tells you that it sent back the default HTML. Like I said, you could change that if you wanted to analyze this further, which I'm not going to do here. I'm not going to pull down that payload because I don't have a ready non-attrib machine built to pull it down. You could also look for it on VirusTotal as well, I'm sure, and pull it down that way. But for now, what I really want to show you is this guy, jd-gui, which is installed by default on Remnux. And if we take either one, actually, let's actually take our, I was going to do it on the Adwind sample, but now that we know that this is a dropped jar file, let's go ahead and extract. Oops, I do need to use my terminal though, in a new tab. Let's go ahead and use this for our example here. We'll pull this into jd-gui, and jd-gui, if you haven't used it, is pretty much dnSpy without the debugger for Java archives. So you can go through here and you can actually get back the high-level code in Java of what this malware sample is doing. It's not perfect, but it gets you pretty darn close for the most part, and you can go through these classes, which I'm not going to do right now, but you can go through these classes and you can get a look at all the pseudo high-level code that is part of this file. Now, the other tool we installed on here that was not in Remnux by default is very similar. In fact, it has jd-gui built in as part of it, but it is called Bytecode-Viewer. And if I remember, we just stuck it in our home directory. Yep. And you just run it with Java, tac-jar, Bytecode-Viewer. And we can drag our jar file in here. And the reason I like to put this one in here in addition to jd-gui is it has multiple decompilers available. So if I go up to view here and I select pane 1 is, we can set that to jd-gui, just like we should get a similar result as last time. And then these are all different Java decompilers. Like, again, I'm probably going to butcher this. I'm not actually sure if it's Procyon or pronounced differently. I've always mentally called it Procyon, so I'll set that in pane 2. You can even add a pane 3 to compare with like something like Fernflower, or even just looking at the raw bytecode. And let's refresh down here. And we can get a side-to-side comparison of these different decompilers, which will sometimes have vastly different output. This one doesn't look too terribly different, but sometimes, like this is a good example, you'll get, not vastly in this case, but slightly different output depending on which decompiler you're using. So this is really handy if you're doing Java malware analysis to kind of get multiple views and trace through and see if you can figure out which decompiler makes the most sense for you. And you can go through and, again, run through all these classes and try to figure out what's going on. So it's very close to having the original source code. It's not going to be perfect like any decompiler, but this is a really handy tool, as is jd-gui on Remnux. So I just wanted to quickly show off Bytecode-Viewer. If you are interested in learning more, these are pretty terrible papers, to be honest, because it was very early on in my malware analysis career. But I do have a couple of Java malware samples that I used Bytecode-Viewer and jd-gui on, I believe. I have write-ups in them in my GitHub under malware write-ups. These are the only two write-ups I have there right now, because since then, most of my write-ups are done for my day job or for people under NDA. So I don't have a lot of, public write-ups available outside of my videos. Apologies for that. But if you open these, you can take a look at how I used jd-gui in this case, Bytecode-Viewer in this case, to go through and analyze these and pull out their functionality. And it's a really cool, I remember this being a really cool first delve into Java malware. So yeah, just wanted to point that out. Again, I'm not going to get too deep into these particularly, but just showing you all the available tools at your disposal in the lab and how you can kind of pivot around and go back and forth from your victim machine and just kind of monitoring, looking for IOCs, to really doing some deep reversing on either your Windows machine or on your Remnux machine even. And there are, I believe, some other Java-centric tools here. There's jadx GUI, which is another kind of decompilation GUI that you can look through. Again, always nice to have options. This one's a little bit nicer to look at, I will say, than Bytecode-Viewer, which is nice. Yeah, I'm sure there's also a ton of functionality that I'm skipping over, like searching and regular expressions and stuff like that. You can go through and look through here. So this is a good example. I just did a quick search for .zip and I got pulled into the main file, and you can really see just exactly the kind of timeline of what we saw on the Windows machine. You see an HTTP connection built up. It does look like there's some basic encoding at play here. You could probably write something to decode these strings. You can take a look here. It looks like we might be doing just a quick XOR. In fact, now that I see this, one second. Oh yeah, look at that. You can just recreate that in Python and you can get server socket back from that one string that was passed in. But yeah, that's one way to do it. Or you could, I don't know if you can do it in jadx or jadx, but I know in Bytecode-Viewer, you can take file, decompile, and save all classes and save them to a zip file, which you can then open in something like NetBeans or your favorite Java IDE. And that's exactly what I did with those two papers I pointed out. And I was able to actually get them to run dynamically, just like we do in dnSpy, doing that. And as you saw there, I just selected a decompiler to use, and I was able to dump them to... Where did you dump them to? Did I save them to my home directory probably? Yeah, I sure did. I thought I dumped them to my downloads, but is it my home directory? Right here, I think. Yep. I don't know why I called it downloads. Probably because I messed that up. But yes, right here are all the decompiled Java files. You should be able to load those into something like NetBeans, do a little bit of configuration on the project, and yeah, you can run through them dynamically. Really cool. All right, I think that is really about it I wanted to show on Adwind. We've got one more sample, and then we will issue your challenge and call this one a course. All right, this last one we do want to be very, very careful with because it is a sample of Royal Ransomware. So we're definitely going to go in, take off our shared folders so that nothing gets ransomed in there. Once we copy it over, we'll extract it. And let's go ahead and set up INetSim. That'll be all we do in Remnux for now. Let us get this file name, this long hash, and put that into procmon as our process name filter. What else do we want to do? We could open Wireshark. We could open any of these tools, really. Let's go ahead and run it through Detected Easy, see if there's anything interesting there. Yep, just tells it it's C, C++, nothing crazy. The biggest, I don't know if I mentioned it in part one exactly, I probably did just briefly, but the biggest benefit of Detected Easy that I use it for is if there's a packer or obfuscator in place, you can use it for that. In this case, don't see too much there. We could set up, let's see, System Informer, of course. And I think that's really all we'll need for this one. I'll use INetSim instead of popping over Wireshark because due to the nature of ransomware, once we run this, things are going to get encrypted real quick. So let's see what happens if we just run it by itself. We get some of the basic libraries being opened, some registry key activity. Yeah, we see a lot of file system and registry activity, but not as much as we would hope with ransomware. So what gives? Well, let's use this opportunity, and I know I've used this in many of my past videos, but let's use this opportunity to open up x64 debug, my favorite debugger, and let's throw in the ransomware and see what's stopping it from fully reaching its ransomiest potential. It's telling me that I actually need to use x32 debug, which makes sense. I should have known that from the detected easy output. That this is a 32-bit executable. We just need to go to here, release, and go under x32 debug. And let's pull that right back in. And let's just, what I like to do, if I know not everyone here is going to be a guru at debugging and assembly, and if you aren't or would like to be, I do have a couple of other videos, including our last masterclass. What am I doing here? I need to go to options, not that one. Not that options, but appearance. You can go to my last Master of None course about x86 assembly if you're interested in learning more. I'm just going to bump up our font sizes here to make this a little bit more legible. Yeah, I think that'll be good. And what I will do, if you don't know anything about debugging or disassembly, what I typically am going to do is, or if you know very little, a good way to go about this is just to go to the entry point here and just step through step by step and see which function call that you see an exit on or directly after. That'll narrow down where we should put our focus. So in this case, we're getting all the way down to, what is that addressed? BE, C4, and then we have a jump, EC, and then another jump, and we have 0A, call this guy, and then it quits. So that's where we should probably focus our attention, is wherever that last method was right before we saw that exit, which was, it must have been after jump because oh no, right here, there it is. Let's set a breakpoint there, and then let's step into this function and do that exact same thing again. Just take a look at what's going on when we get that exit. So in this case, we're seeing a couple calls to read the command line, which is right now just the file name itself. Let's see what happens. All right. And I'm noticing, if you look right here, the character 2 is loaded into EDI and onto the stack. I'm wondering if that's telling us, yeah, so right here, this string compare. Let's see what we got here. All right, I just went and added a few breakpoints ahead of time so you didn't have to watch me just slowly click through all these commands here, but I'm going to point out a few highlighted areas to home in on here. So right here, like I said, looks like we are looking at either a comparison against TAC path, TAC ID, TAC EP down here, and then no more flags, but there is an interesting string here, which if you've dealt with ransomware of any kind, you might be familiar with. Looks like it's deleting shadow copies. And what that means is, if you're not familiar with shadow copies, there's a service, a VSS volume shadow service or volume shadow copy service in Windows that basically makes like versions of your file so that if you need to recover a file, you can do that. And this deletes those, what they call shadow copies, so those other versions of that file. So the intent of this for ransomware is to make sure you have no chance at recovering any of your data once it's encrypted. So that's interesting, but more important to the matter at hand, it looks like we're failing out because we don't have the right command line flag. So let's take one of these. In fact, I'll just keep going through here. It looks like it still does call delete shadow copies, and that's about all it does before it exits out. Let's restart, and this time, let's specify TAC ID and see if anything changes. Well, we get back to this point, and we'll go through here, and I'll actually skip ahead down to, well, I'll just let it run. There's a function that I put a breakpoint in when I found it. I just basically stepped through over and over and over again until I found where it does the comparison, and it is below here. So this is actually, so right down here, while we're on our way to the point that I want to make, this is actually creating the process for vssadmin.exe to delete those shadow copies. So that's really interesting that it does that regardless of if it does the encryption. But let's keep going. Right down here, we do a string length call, and you notice it's 0. That's because that's the string length of our ID. And if you wanted to compare that, or if you wanted to confirm that, let's go ahead and rerun this. I'll set a breakpoint there, and let's just make it 1, 2, 3, and restart. And let's wait till we get to that line right there, and we can see now that it's 3. So it's getting whatever's after the ID flag and comparing it to hex 20, which is 32. What does that mean? Well, if it's not 32 characters or bytes long, it exits. That means that we need to add an ID at least of 32 characters. And we could confirm that, by the way. If you look up any sort of report on Royal Ransomware, which is, by the way, if I remember correctly, it's the predecessor to Black Suit ransomware, which was the recent one in that big CDK breach that affected a bunch of car dealerships, if you're in tune with that news. But regardless, you could look up any analysis of Royal and find out exactly what these 3 paths are, because some other analysts did the hard work to find out exactly what they were. You can see that path is the path to be encrypted, EP is the number that represents the percentage that will be encrypted, and ID is used as an identifier. It won't run if it's not specified. Well, let's see what happens if we make that 32 bytes long. So I'm just going to keep entering dummy values here. 5, 6, 7, 8, 9. That'll give us to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. 20, math, 27, 28, 29, 30, 31, 32. See how that works. This time, we get down to our check here, and we are at exactly 32 bytes. Before we get started, let's make sure of a few things. Let's make sure we've turned off our shared folder so it doesn't get ransomed. It's indeed off. And let's set a filter on in procmon. Oops, not on parent ID, but on process name. On this big process name here. And let's see if its behavior changes now. Spoiler alert, I think it will. Let's go ahead and press play. And we can see immediately a bunch of entries, and I don't even have to show you. You can see, you can see in procmon easily, it's iterating through all of my file system, but I don't even have to show you that because already I'm seeing ransom notes on my desktop here. And you'll notice when we pop open these ransom notes, it'll let me, my RAM usage is getting really high as it encrypts everything. Hello, if you're reading this, it means you were hit by Royal Ransomware. And you'll notice that our ID was appended right here. So this is how that ID is used by the ransomware operators. It ends up being the same ID that you'll use to go contact the ransomware operators and negotiate your ransom. Pretty cool that we were able to look at that in the debugger and figure that part out. So now we can get a bunch of good detection signatures from the ransomware. We can figure out exactly which paths it goes after, which it doesn't appear to be very, restrictive in which paths it goes after. It looks like it's going after just about everything. We've got their onion site there. I don't know if we'll see any network traffic in this case, because typically data exfiltration happens separately from this encryption, but we can look and see if anything pops out in our log here. And it looks like there was some enumeration maybe of some other local IPs, but other than that, I don't see anything outside of some Windows and Google noise in here from the ransomware itself, which is, again, to be expected. This is usually, the encryptor usually runs on its own. We do see, yep, is this the same process? Yeah, we do see that some traffic right there, actually. That might be, oh yeah, that's Microsoft DS. So that's what I want to say. Domain service? Is that what it is? I'm just making sure that I don't tell you something wrong. Directory services, duh. Sorry, SMB traffic. So yeah, it's looking across the network to see if it can spread to somewhere else, which is why we're seeing those entries for some local IP addresses on the subnet. In fact, you can see it iterated through our entire subnet because we have a /29 mask. We've only got a few hosts on here, and it iterated through all of them to see if it could kind of get into something else and spread. So that's really cool. So yeah, we got some good indicators out of this. All the rest of this is basically just all the encryption. One thing I'm surprised we don't see, at least not in the process, well, before I speak, let me search for the path, is that call out to VSS. Maybe it did show up and I just missed it in all the noise. So no, that's just the ransom. I mean, if we did process name contains VSS, we'd also filter on that, and we should see, oh, we actually don't see. Interesting. I thought we would at least see VSS admin run. Is it only if you do it without, did I run this after running it without the command line? Okay, that's weird. I don't know why I didn't see that before when I filtered. Maybe I completely missed it, but yeah, there you see the call out to VSS admin. It's also important to note that create file as an operation is a little misleading. That operation gets called regardless if it's creating a new file or accessing an existing file. So it doesn't mean that it's creating that file. The malware's not creating that file. It's just opening it, accessing it. And you should see that call out to shadow copies if you're monitoring vssadmin.exe. Now what's curious is that I have a filter for that. I'm wondering if it may filter out, it doesn't look like it filters out that. I don't know why I'm not seeing a separate entry for vssadmin considering that it was run. That's really interesting to me. If anyone knows the answer, please leave a comment, but I'm not sure why I'm not seeing anything else aside from that that create file. Maybe it doesn't run the full command and I'm just misreading what's going on with that process. But regardless, we got everything we wanted out of the ransomware. We got good ransom note. We got some network indicators in that the onion site at least. We know that it's going to delete shadow copies. We know now how the command line options work and that it needs to be present as an ID in there. So yeah, really cool little example of how you might analyze ransomware in your malware lab as well. So with that, let's go ahead and close this and restore our snapshot. All right, guys, with that, there's only one thing left to do. We have learned a ton between part 1 and part 2 of this Master of None course, at least I hope you have, and it's time to put that knowledge to the test with a CrackMe challenge similar to the one from our previous course, the x86 Demystified Master of None course. So the new one is not up yet, but it will be in our GitHub repo that's in this video's description, just like this. There'll be a crackme.zip with an executable in it. Feel free to run antivirus or whatever against it, upload it to VirusTotal, whatever you want to do, because it is not real malware. It will simply emulate some of the behaviors of the malware that we've looked at so far. And the true intent is to get you to run this in your lab. It doesn't have to be the lab that we built here, but whatever lab you want to use, and attempt to extract all the information asked of these questions in this Google form. Now pay attention to these parentheses because you want to make sure you're entering the flags just as they describe here, or else you won't get credit. The Google form does all of the validation within the form. So assuming all your answers are correct, you will be added to a similar file as this one, a wall of fame, with your name and the date that you did the CrackMe challenge. And again, if you have a write-up that you end up doing associated with it or some other site you want to share, let me know and in a comment or a DM or whatever. Now, if you have any issues with the Google form, just let me know. If the validation's not working, you can DM me or leave a comment and I'll make sure that it's a validation issue and hopefully fix it if it is, or I'll let you know that your answer is incorrect and maybe clue you into what's incorrect, at least as far as syntax with your answer if you do have issues. But yeah, that will be, again, the form will be in the description of the video and the wall of fame will be in the repo, which I will put together after I package everything up for this video. And with that, that's really all I have left to do. I really hope you have enjoyed this time we spent together building this malware analysis lab and then checking out some real life malware samples with it. And I really hope you enjoy the CrackMe challenge, because that's one of my favorite parts, is reading about the successes that you all have and the learnings that take place after these Master of None courses. With that, I'm Jeff of All Trades. Thank you so much for joining me for this. Again, apologies that it took so long to get this one out, but I really hope it was worth the wait. Please let me know what you think in the comments below, and I look forward to seeing you all in the next video, wherever that takes us. Never stop learning, keep on sharing your knowledge, keep on contributing great things to the community, and most of all, have fun. See you next time.